Hello everyone, I am Professor Amit Solanki. Today we will discuss the power electronics topic, that is the switching characteristic, or we can say that the dynamic characteristic of the thyristor or SCR. As we know that thyristor have two types of characteristic, which one is first, that is the static characteristic, and second one is dynamic characteristic. So in previous lecture we have already discussed the static characteristic. Now we will discuss the dynamic characteristic. So dynamic characteristic is generally divided in two parts. One is during turn on time and during turn off time. So let us discuss what are their function, what are their specification for the dynamic characteristic of SCR during the turn on time. As we know that according to the static characteristic of SCR, a forward bias SCR can be turned on by applying a positive voltage between gate and cathode terminal. The SCR comes from forward blocking mode to forward conduction mode by applying the positive gate current. Okay, but it takes some transition time to go from forward blocking mode to forward conduction mode. As you have observed that in VI characteristic of SCR, that means the SCR take time or take some transient time to go from forward blocking mode to forward conduction mode. And this transition time is called turn on time of SCR. So this time is called as turn on time of SCR or turn on time of thyristor. And it can be subdivided into three small intervals. These are the three intervals of the turn on time of SCR. That means what time the SCR taken to go from forward blocking mode to forward conduction mode, or we can say that from off state to on state. So turn on time of SCR is divided in three parts. One is delay time, second one is rise time, and third one is spread time. So one by one we will let us discuss the phenomena of different time interval. So first we will discuss the delay time of SCR. What do you mean by delay time of SCR? The delay time of SCR, that means the after application of gate current, the thyristor will start conducting over a very teeny region. So therefore delay time of SCR can be defined as the time taken by the current, the time taken by the gate current to increase from 90% to 100% of its final value of gate current. So this is the function or definition of the delay time. From another point of view, we can also define the delay time. That means the delay time, it is the interval in which anode current rises from forward leakage current to 10% of its final value. And at the same time, anode voltage will fall from 100% to 90% of its initial value anode voltage. These are the another definition of the delay time. So these are the concept for the delay time. Now we can define, we can understand the definition of the rise time. What do you mean by rise time? The rise time of the SCR or thyristor is the time taken by the anode current to rise from 10% to 90% of its final value. That is called the rise time. And this time, at the same time, the anode voltage will fall from 90% to 10% of its initial value of anode voltage. That is called the rise time of the SCR. So you can see that in case of rise time, the anode current is rises from 10% to 90%. And at the same time of rise time, that means anode voltage will decreases from 90% to 10%, just opposite. Anode current is increases, but anode voltage is decreases. So this is the phenomena for the rise time. The phenomena of decreasing anode voltage and increasing anode current is entirely depends on the type of the load. Okay, so this is the most important thing. The increasing and decreasing of the anode voltage and anode current, this is totally depends on the type of load which type of load we have connected to this thyristor. And for example, if we connect the inductive load, so then what will happen? The voltage will fall in a faster rate than the current increasing. But previously, identically, we have seen that 10% to 90% and 90% to 10%. This is the fix. But if we are consider the load is inductive, so in that case, the voltage will fall in faster rate as compared to current increasing, right? So this is the happen because induction does not allow initial high voltage change through it. So according to the property of inductor, we can say that this is the happen due to their property, their characteristic of the inductor. So this is about the concept of the rise time. On the other hand, if we connect capacity load, if we are talking about the capacity load, so it does not allow initial high voltage change through it. That means as current increasing rate is faster, will be faster than the voltage falling rate. Just opposite in case of capacity load. So if you are connecting different types of load, so their rate of change, their rising, their falling rate is different. Okay, so these are the we can say that the rise time. High increasing rate of DI/dt can be create local hot spot in the device which is not suitable for the proper operation. Okay, if we are increasing the high rate of DI/dt, it can create the hot spot. So therefore, that will be harmful for the device. So it is advisable to use inductor in series with the device to maintain high DI/dt. Okay, so this is the some advice, or we can say that the limitations to use the inductor in series. Usually, value of maximum allowable DI/dt in the range of 20 to 200 ampere per microsecond. This is the range for the DI/dt. Now we can define the spread time. So let us understand what is the function, what is the definition of the spread time. So spread time, it is the time taken by the anode current to rises from 90% to 100% of its final value. In case of delay time, we have seen that the anode current is rises from 10% to 19%. But in case of spread time, the anode current is rises from 90% to 100%. And at the same time, the anode voltage decreases from 10% to its initial value to smallest possible value. So in that case of anode voltage, the anode voltage is fall from 10% to initial value. And in this interval of time, the conduction is spread all over the area of cathode and the SCR will go to fully on state. This is the some specification of the spread time, and this is depends upon the cross sectional area of the SCR. Okay, so this is the spread time is depends upon the cross sectional area of the SCR. Now you can see that in this graph, in this figure, you can observe that as we have told, as we have earlier discussed, the different time interval of the switching characteristic or dynamic characteristic of the SCR, which is the turn on time. The turn on time is divided in three intervals. One is rise time, delay time, and spread time. This is the total time. This is the turn on time. So in that switching characteristic, you can see here one by one, step by step, anode voltage VA and a gate current IG. This is the graph. First, we will discuss the T of D. That means that is the delay time. T of T, that is the spread time. T of P, that means that is the spread time, and T of R, that is the rise time. And this time interval is, this combination of time interval is known as T on time. Okay. In delay time, you can see here what will happen. This is the gate current, and this is the anode voltage. This is the increasing. Okay. This is also as per definition we have seen. So these are the all about the concept how to graph is plotted according to we earlier understand. Okay. Now we will discuss about the dynamic characteristic of SCR during the turn off time. What are the characteristic dynamic characteristic of SCR during the turn off time. In that what we see, okay, so now we will discuss the dynamic characteristic of SCR during the turn off time. So during the turn off time, once the thyristor is switched on, or in the other point of view, the anode current is above the latching current, the gate losses control over it. That means we can say that the gate circuit cannot turn off the device. For turning off the SCR, the anode current must fall below the holding current. Now, in case we can see that the anode current fall to zero, we cannot apply forward voltage across the device due to the presence of carrier charges into the 4 layer. So we must sweep out or recombine these charges to proper turn off of SCR. So turn off time of SCR can be defined as the time interval between anode current falls to zero and device regain its forward blocking mode. This is called the turn off time of SCR. So according to that, on the basis of removing charge carrier from the 4 layer, the turn off time of SCR can be divided into two time regions. Which one is? First one is reverse recovery time, which is identified by denoted by the T of RR, and gate recovery time. These are the two interval of the turn off time. So first we'll discuss the reverse recovery time. So it is the time interval in which the charge carriers removed from the junction of the J1 and J3. During that time, at time T1, anode current falls to zero and it will continue to increase in reverse direction with same slope di by dt of the forward decreasing current. And this negative current will help to sweep out the carrier charge from the junction J1 and J3. At that time T2, the carrier charge density is not sufficient to maintain the reverse current. Hence, after T2, this negative current will start to decreases. And the value of current at time T2 is called reverse recovery current. So due to a rapid decreasing of the anode current, a reverse spike of the voltage may appear across the SCR. So therefore, we can say that the total recovery time, that means T3 to T1, is called the reverse recovery time. After that, device will start to follow the applied reverse voltage and it gains the property to block the forward voltage. Now we are discussing about the gate recovery time. Let us explain about the understanding the concept of the gate recovery time. After sweeping out the carrier charges from junction J1 and J3 during reverse recovery time, there still remain trapped charges in J2 junction which prevent the SCR from blocking the forward voltage. And this trapped charge can be removed by the combination only, and the interval in which this recombination is called the gate recovery time. So these are the basic definition of the gate recovery time. Now again, when we have see the graph, so according to graph, we can understand it easily by the switching characteristic of the SCR. So in this graph, you can see here. So now we will discuss step by step total the switching characteristic concept. So in that switching characteristic, there are two time interval. One is during the turn on time or during the turn off time. So turn on time is divided in three intervals. One is delay time, rise time, and spread time. As it is, second one, that is the turn off time, is divided in two mode of interval. One is reverse recovery time and second one is gate recovery time. So in that figure, in that switching characteristic, you can say that what do you mean by TD? TD means that is the delay time. So what will happen in the delay time? That during the delay time, the gate current is increases from 90% to 100%. Okay. So this is the gate current in that during that time, it will increases from 90 to 100%. According to graph, you can observe here. And at the same time, delay time, the anode voltage is falls from 100 to 90%. As you can see in this graph, that is the anode voltage. This is the line of the anode voltage. In that you can see here, this is the anode voltage. It is decreases from 90% to 100%. Sorry, 100% to 90%. Okay. As it is, next part, that is next interval, that is the rise time. In that rise time, you can see here what will happen. The anode current is increasing. Here rises from 10% to 90%. As you observe, you can easily observe in this graph what will happen during the rise time with respect to anode current. Okay. So anode current is increasing or rising from 10% to 90%. Okay. And same time, the anode voltage is increasing from 90 to 100%. Okay. As it is, if we are defined, we are talking about the spread time. So during that spread time, the anode current is increasing from 90% to 100%, and anode voltage is decreasing from 10% to their initial value. So these are the all about the concept for the turn on time. As it is, you can see here, this is the small T1, T2, T3. This is the reverse recovery time, and this is the T4, T4, T5, T3, T4. This is the gate recovery time. So these are the all about the concept for the dynamic characteristic or switching characteristic of the SCR. Thank you so much.